Today I'm going to show you guys how to recover lithium from a lithium battery. This is very similar to a way that lithium is recycled by first converting it to lithium carbonate. We're going to start with a pipe cutter. We're just going to slot the pipe cutter into the divot on the positive side of the battery and slowly rotate it until we cut all the way through the outer steel protective casing. Now, I just want to preface this with a disclaimer. Please don't do this at home. It's very unsafe and you could cause a lithium fire or a short, both of which are undesirable. So we've cut all the way through the battery at this point, and I can now slowly start to remove the positive side of the battery. But I also have to remove the negative side, because if I don't, then it will cause even more shorts. So I'm going to cut all the way through the negative side, and at this point, we can now start to remove the outer, almost paper-like casing and start to unroll the lithium metal on the inside. Now, this lithium metal is extremely reactive with the moisture in the air, and so it quickly tarnishes. But as I quickly unwrap it, you can start to see the silvery lithium on the inside. It's this long foil strip in my hands now. I'm now going to roll up the lithium to prevent any more air from getting to it and putting more of an oxide coating on it. We're also going to remove this steel tab to prevent contamination in the final product. Now, we're going to start with about 350 milliliters of room temperature distilled water. As you can see by the thermometer, the water is at 20 degrees Celsius, which is room temperature. We're going to slowly pick off very small pieces of this lithium, because if we put too large of pieces in it, it may cause a fire. We're going to take these small pieces and slowly drop them into the water, and as they dissolve in the water, they form hydrogen gas and lithium hydroxide. This is an incredibly basic solution, and we have to watch out and be careful not to get our hands in it. Now, the next thing we're going to do is continue to put the rest of this lithium in the water, and as we notice, the water starts to slowly rise in temperature. It's currently at about 22 C, and after putting the entire first piece of lithium in it, the temperature is close to 45 degrees Celsius at this point. I'm going to continue to add the rest of the lithium, and at this point, once the lithium is all added, we can begin by filtering off all of that gunk and remaining electrolyte left in solution. I'm going to pass this through a standard coffee filter, and then pass it through a 1 micron particle filter. The reason I do this is because a coffee filter should suffice for getting all of the electrolyte out, and the particle filter will get the rest of the small stuff out. Now, I did run out of beakers here, so I did have to use a Pyrex, but it really doesn't matter that much as long as the glassware is clean. I'm going to let this play through so you guys can watch it filter all the way through. Okay, at this point, I'm ready to begin my next step. The goal here is to bubble CO2 gas through the lithium hydroxide mixture. We're going to do this by bubbling acid through a super basic solution of sodium bicarbonate and sodium hydroxide, which will produce CO2 gas that we can then bubble through the mixture, and this will form a crystalline precipitate of lithium carbonate. Now, I cover this up just to prevent the tube from coming out and secure it with a zip tie. As we can see here, the mixture is already starting to become more opaque as lithium carbonate, which is less soluble in water than lithium hydroxide, precipitates out. I'm going to speed through these clips just so you can easily tell where it really begins to show. At this point, our solution is much more opaque, and I'm about to test the pH because our goal pH is about 8 or 9. That'll tell us that almost all of the lithium hydroxide is converted to lithium chloride, but at this point, we have a pH of closer to 10. So I'm going to keep it going for another 10 to 15 minutes, and then we'll test the pH again and hope we're closer to our goal of 8.5 to 9. Okay, I'm about to test the pH again here, and we've dropped down to about 9.5. As you can see, it's much, much less purple and more blue, but we're still not quite in the green that 8.5 or 9 is. So now I'm just going to pull it off the hot plate because it's pretty much done. I'm not worried about the pH at this point. It's been taking too long. And as you can see, there's a nice amount of white precipitate on the bottom. This is lithium carbonate. So I'm going to slowly start to boil and stir it, and our goal here is to get it to about 75 degrees Celsius and then slowly raise it all the way up past boiling to about 160 degrees Celsius. As you can see here, it's about 46 degrees Celsius, so we got a little bit of a ways to go. Now at this point, it is at a rolling boil, and all of the lithium carbonate should be in solution and as a precipitate. Lithium carbonate's interesting because the warmer it gets, the less soluble it is in water. So I've stopped boiling, and now I've decided to start pouring the lithium carbonate and the resulting water through another filter because I need to separate all the white powder from the liquid. As you can see, all of the water that's coming through is completely clear, and at this point I'm going to wash all of my lithium carbonate with boiling distilled water. It's boiling because we don't want any more of the lithium carbonate to dissolve while we're washing it. So now at this point I have pure white lithium carbonate after letting it dry for a few hours. Lithium carbonate is such an interesting compound. I think that it's definitely a step forward in the right direction where we can start to recycle lithium, and potentially in the future we'll even be able to completely recover all lithium used in batteries, which will provide less of an impact on farmers and people who depend on water to survive.